Hello, good evening, and welcome to the 9th edition of Better AI Meetup. We are almost at 10th edition, so I'm really glad, and we are also almost full. We should be full, but there are probably still some people missing, but we have lots more on streaming. And yeah, this makes me very happy because this looks like it's very lively, and we want to continue this. And I'm also aware that you are probably drawn here due to the fact that we chose a topic of life and death today, because we will be talking about medical AI. But before we even start, let me introduce Maria Bielikova, head of our co-organizer KINIT, who will be explaining the upcoming AI awards by KINIT. So please, Maria, the floor is yours.
Thank you. And hello, everybody. Dear ladies and gentlemen, I am very honored that I can announce these AI awards. This year is focused on trustworthy AI. It's very nice that the announcement, actually the first announcement was last week on ITAPA conference, but in Better AI Meetup, in this community, it's with this topic, health, which really needs trustworthy AI. So I would like to encourage you and your friends to apply. Actually, we are looking for organizations and teams developing, I can tell, AI-intensive systems, so systems that include somehow AI. And it's important that for this award, it's not just something we will look at it superficially, but we will very deeply look at trustworthiness of your development based on assessment list for trustworthy AI, which is developed by a high-level expert group on AI, which was established by European Commission. It's somehow a small preparation for AI Act, but not, you don't need to be afraid, because just expert will evaluate and there will be no winner, because all product that will be assessed will be winners. And for Slovakia, it's really important to have as much as possible product which will show that we are aware of different attributes of trustworthiness. We want to have a feedback. And for all the finalists, not just laureate, you will get not just feedback, but promotion. And it's important not just for your company, it's important for the Slovakia, because Slovakia on the AI map is very, very small. And this can bring us really on the map. There is quite a lot of interest from abroad as well, from European Commission as well. So please use your network, ask your colleagues in your company, ask your friends in other companies, just show us what you are doing, what we are doing together in Slovakia. And every submission is important, because as much submissions we will have, the competition, the award will be stronger. So the time is like 2 months, February 9th. So if you have any questions, just write us. The award is organized by Campbell Institute, by Hopero project. But first of all, I have to mention the Commission, the Committee on Ethics and Regulation on Artificial Intelligence, which is a body established by Ministry of Investments. And the experts from this commission will be in the jury and evaluating the products. So thank you a lot for submissions, and I wish you a pleasant Better AI with a health topic which really needs trustworthiness.
Thank you, Maria. KINIT is as I mentioned, co-organizing Battery AI Meetup. The other organizer is Innovatrix, and this time we also have a support from Nadacia VSE Foundation, so I want to thank all of them. Yeah, please check out the AI Awards. We will be definitely applying at Innovatrix, so if nobody else applies, we win by default, which is fine by us, but probably not by you. As we already mentioned several times, we will start with topic of medical AI. And first, I want to invite our first guest, Milan Unger from Siemens Healthineers, and we will be talking about AI in medicine and especially in radiology. So Milan, please, welcome. Yeah. Thanks. So first we will start with some questions and answers on a medical topic. If you have any questions, you can post them in our Slido, which is available with a hashtag BetterAI, and you can post any questions, and we will answer them after the presentation of our second guest. So, but don't worry, we will be trying to answering all of them. Milan, let's start with, Milan is with Siemens for over 20 years, so he knows basically everything there is that's happening there. Yeah. So how does AI currently help in medicine as a whole, or where is it used mostly?
So if we speak generally about the medicine, you also can take various aspects. Some of the aspects are related to the clinician, some are related to the patient, and some are related just to the operations of the hospitals. And you can basically find in all these areas some aspects of the AI already applied. If we start from the operations, such tasks like the simple shift planning, there is also already some applications which use the artificial intelligence. If we go to the patients, there are various patient management tools where you need to actually communicate with the patients or simply track the patients, how they behave, how you can affect their engagement in their treatment of the disease. I think what we want to speak here mostly is about the clinicians,
How does AI help the doctors?
AI helps the doctors, helps the clinicians.
Yeah.
So there are various applications already. But when we speak about the medical devices, then we will need to be also quite careful because that's strong regulations with the medical devices. And you need to apply through the regulatory process. But you have a lot of so actually I checked how many are already listed by the FDA, and there is 700 medical devices with the AI applied in the device already registered. Okay. Yeah. Most of them is in the radiology, which is quite natural, we can discuss, but this is also in the other areas. And another aspect is the pharma, where you have actually AI applied in the development of the drugs. Yeah. So new drugs actually are starting to be using the artificial intelligence to generate the models of the drugs, of the molecules and whatever else. I'm not a pharma expert. Yeah.
You mentioned the radiology. Why is it being used in radiology so extensively, and maybe what are the advantages, and how does it compare to trained radiologists? Because being a trained radiologist is like really a long-term activity, and you don't become radiologist by just going through school.
Yeah. So yes, I can tell. First time I was in the office on the project of radiology, and I look at the screens where the other people were looking. It was for me just black and white noise. Yeah, you cannot read anything. You really need to be trained, and even now, I think you cannot compare with the experienced radiologists, because that's really the training. Why is it used in the radiology? So one thing is that if you look at the radiology in the Röntgen, which is more than 100 years on the market, it's connected to electricity. This then was moved to the computed tomography. And if you speak about the computed tomography, you basically need the computers. You cannot generate the images without the computers. So it was quite natural that there was the close connection between the computers and the radiology. And one of the aspects, why you need actually this AI is that imaging, medical imaging is quite valuable diagnostic tool and also other tools, but especially diagnostic tool in the clinical workflow. But it's also quite costly. So there is around 400 millions of scans, CT scans every year worldwide. And if you count it, you will end up with some 10 scans per second. But one scan to get from the scan to the report generated by the radiologist, you will need approximately 20 to 30 minutes. So if you just compute it, you will get the numbers like every second, and if we count the 24/7 every day, there is some 10,000 of radiologists finishing the report and providing some results. Now, of course, this is just growing. We have the new CT scanners, which generates more data, so it actually means that the radiologists need to check and read more, and actually also the requirements are higher and higher.
Yeah, so basically they need help.
They need help, yeah. And other aspect is that what they do is not like you take the image and then just count some numbers. You actually need to use your cognition. So you need to actually interpret. You see the image, but in the image you see somebody, but it's not like you see something and this by definitions means that this is, for example, on cancer. It could be anything. It could be even the artifact from the scans, from the computed tomography. So they really need to be trained, but they also need to get help. And for this kind of the help, where actually you are depending on the cognitions, if you want to automate it somehow, you basically need artificial intelligence or some applications of artificial intelligence to help them.
How are actually, in our domain in biometrics, we talk a lot about false positive, false negatives with AI. How is it treated in medical domain? Because getting a false positive or false negative can actually mean like life or death for a patient. So I'm assuming that AI is in this way treated quite differently than in other domains.
Yes, of course. So one thing is that you need to be aware of this fact. And you need to be, and also the radiologists need to be aware of this fact. And being aware of this fact is not satisfactory because you can easily run into the overtrust problem. So if this is good in 90% of the time, then the users, the radiologists, start to believe too much to it. So when you are designing these tools, you actually need to provide something where you will ensure that it's reviewed, what's provided as the output. So usually you need to design the system in the way that it requires the review, or it's not like that AI will send you to the surgery. That will not happen. That's still the problem. There must be human who will do decisions. It's also not the case that the output or analysis of the image will result to the report automatically. There are some automations, but from the AI finding to report, there needs to be human. So this is something which is basically required in the radiology and in the medicine in general. I often try to compare it to commercial business. In commercial business, if you can get from 50 to 55% success rate, you are good because you get 5% of extra. But in the medical devices, if you are 90% precise, you still need to speak about his every 10 patients possibly misdiagnosed. So we have this. We have also the problem of overfitting. We have problems of overtrust. But generally speaking, when you will register your device, you need to address the risks. And this risk must be reviewed, and you need to explicitly say how you mitigate his risk. So what are the mitigations to avoid possible harm to the patients?
How long does this process actually take? I mean, to register your device and come through this process, because I'm assuming it will be really thorough.
It depends. It depends on which kind of the device you are trying to register, and it depends also on the countries. So I don't know the exact numbers. I know it takes months if you're going with comparing your device to already existing solutions, or maybe longer if you do de novo, new solutions. In some countries, it could take like 16 2 years. Yeah. In some countries, it's quite more fluent, like few months. Yeah. So there is no exact number. What you will need to have is to have the proofs, yeah, and to provide the proofs, to provide some evaluations. You need to compare to how radiologists will behave with this. So basically, you have always intended purpose, and you make some claim that this is how these solutions will help the clinicians, and then you need to prove that yes, I have this data which proves that I'm better, or the process is better, which could mean faster, better success rate, whatever.
How are the regulators actually prepared for AI in the medical devices? Because I'm assuming it's a bit of a different beast than just having like a simple medical device. Than when you have like algorithm that probably needs to be, I don't know, audited, or at least you want to know how it works.
There is already regulations, and there is also guidelines. So especially the FDA already published the guidelines how to work with the AI, what is reviewed, what are the steps necessary. So I would say now they are quite well prepared, especially in the developed countries. It's changed a few years ago, yeah, when there was the rapid growth of the AI. Before there was not such explicit step. It was still reviewed, but it was not such explicit. But also the results or the AI application was very narrow, yeah, and very specialized. Yeah.
What different types of approaches or of AI are being used in medicine? For example, I mean, you mentioned radiology, which I'm assuming it's basically image analysis and computer vision, but there's a lot of LLMs currently being used. I don't know, speech to text, text analysis. What's being used in medicine?
So one obvious in the radiology is image analysis, image recognitions. Yeah. So if we speak about the image analysis and image recognitions, usually it's the detections of the anomalies. But there are also some simple tasks like orientation of the patients, putting on the scanner, because you need to find out, you don't scan whole patients, yeah, you scan just part of the body. So actually to provide which area you want to scan, yeah, so you can take the picture of the patients on the table and then automatically set up, okay, this is this area which I want to scan. Then there are the others like the landmark detections, where you basically just identify various parts of the bodies, which helps then the radiologists to orient and to prepare their reading of the images. Then there are the others like, if we speak about the generation of the reports, yeah, then actually you can use these large language models, for example. Then you have the speech recognitions, which is used already for 20 years, possibly, where the radiologists, while going through the image, they need to manipulate the computer. Instead of writing down what they see, they basically dictate it to the dictation system, and it writes it to the reports, and it's technology which is working quite well now. Another aspect is like scheduling, which findings or which scans take first, yeah, how to organize the work, yeah, how to prioritize the various scans. Yeah. So this is also something where you can apply some algorithms. Usually what's happening is that you combine various techniques. So you use, for example, neural networks combined with some other methods of the classification and such things. But areas are quite broad, yes.
Okay. And yeah, coming back maybe a bit to the radiology, how difficult are actually the data sets to obtain? Because, I mean, if you want to have properly trained AI, you probably need like a lot of data and data sets. And what we are talking is not like, telling I don't know, a turtle from a giraffe, but you are actually looking at all the different perhaps malformities, cell differences, because, I mean, just the tumors are like a number of different, cell anomalies. So
yes. So I said before that there is this 400 million of the CT scans, yeah, but each CT scan has between 100 to 500 megabytes of data. So you need to store it, you need to transfer it, yeah. Then the other task is that, okay, even if you will get the data, how exactly it is problem. You have the task, you want to, for example, make the detections of the lung nodules, yeah. To make these detections, you need to select specific diseases from the scans. Then you get the scans, and you need to annotate and label them. But annotating and labeling means for most of the tasks you need expert clinician, which, as I said, to generate the report, he will need some 20 minutes for the one report, and we are not speaking about the ground truth where you need actually to be much more careful, so it can really take some time. So this actually reduces what you can actually get, yeah, how much you can get given the time scope. The other aspect is anonymization. Yeah, so you got the scan of the patient, and usually in the standard which we are using, DICOM, you have all patients and clinicians' data in the metadata. So you need to get rid of this metadata. But sometimes what happens is you get rid of this metadata, which makes your DICOM data set not usable anymore because somebody took too much. Yeah. But even then, you look at the body of the patient. So we have never-ending discussions when you have really anonymized the scan of the patient. Yeah, because you don't know how it will be used. So this brings the privacy aspects, and this brings the fact that, okay, if you got the data for some purpose and the patients agreed, you need to have the contract with the patients, agreed to have used this scan for some purpose, you basically cannot just broadly distribute it between the project. Yeah? So you need to have really some process to handle this data. Yeah? So this actually reduces amount of the data you can find and make it quite complicated. So there are two solutions possible. You could have your own annotation group, you could have your own team which actually takes care about getting the data. You can work with the data provider, also there are specialized companies which actually deal with the medical imaging data, and they can provide you and generate your data set for the specific diseases or for the specific problems.
Okay, this is nice. And yeah, just one more thing about when you mentioned the ground truth and the privacy. It would be nice to actually have even if you have like trained radiologists looking at the number, when the diagnosis is actually confirmed through other means as well, to be able to get back to the data. And, if you have the personal data, then you can update that, the radiologist was actually right or wrong, just for ground truth purposes. Is this possible when you anonymize the data?
Oh, sorry, I haven't...
is it possible to review the quality of the data like later when you, for example, I don't know, diagnose the patient and you found out that the radiologist was actually wrong?
I'm not aware that somebody do it. If it is possible, I'm not sure if it is possible because of the privacy concerns. So usually you will be not able to go there directly. Yeah. So we have some collaboration partners where, even in the case of the collaboration partners, you need to have special process where if you find out that there's something not fitting the results, yeah, so you see in the, for example, model execution, some anomalies, yeah, then you basically need to communicate with the partner to ask for the anonymization and such things. Okay. So it's possible, maybe possible, but not like you go automatically for it.
It's quite complicated. Yeah, I understand. Are there some benchmark and standards similar to biometrics that are used for benchmarking medicinal AI? I mean, its quality, accuracy, error rates, and so on.
So when we are product developments, and if you go for the product development, your benchmark is usually the current practice. So you basically need to make the claim that, okay, at the moment, this is how the standard of practice works. Yeah, these are the results. And when you will apply this tool, this product, this is the improvement. Yeah, so we always speak about the improvement. This improvement could be at the more success rate, or more precise diagnosis, or it could be in the faster workflow, yeah, that you automated something. So you always need to compare to some results, yeah, to some existing practice, yeah. From the academic point of view, I think it's common, like in the general imaging.
Yeah, okay. So it's like basically internal benchmarking.
Yes.
Yeah, sort of. Okay, and since we are almost at the end, where do you see the future of AI in medicine, and maybe what are the limits of AI in medicine, and what improvements do you see in the in the very near future, in the coming few years, similar to maybe radiology? Where do you see other domains ripe for AI automation and improvements?
Yeah, so there will be a lot of the automation thanks to the large language models, yeah, even if this will require much more specialized models and much more exact results. I think there will be also much more done in the patient engagement, and this will be thanks to large language models, because one of the aspects is communicating the basic facts to the patients. Yeah? And for the experienced radiologists or experienced clinicians, it could be boring, but at the moment there are dedicated humans or personnel who does it. So this could be possibly automated and maybe even improved by using some automated chatbots or agents. Like in the radiology and these aspects, there will be much more AI applied, especially in the preprocessing. So there will be much more preprocessing of the data. So when the radiologist will see the data, he will already have a lot of the task he before or now he's doing manually. He will have already prepared for him.
Okay, thank you, Milan. We have just run out of time. I know about the questions, and don't worry, we will get back to them after the presentation. Thank you so much for your time so far. We will get to the questions closer. And now please let me welcome our next guest, Boris Vavrik, who will actually walk you through a very specific way of going to the market with medicinal AI. So, Boris, this is yours.
Thanks for the word. Thank you, Better AI, for inviting me for the meetup. My name is Boris Vavrik. I'm the head of AI of Powerful Medical. And I will tell you something about the challenges of bringing medical AI to the market. Hi also to the people watching this on stream and also to you in the audience. When I started to do AI, it was roughly a decade ago. I was wondering what will be the toughest part of bringing the AI to the world and benefiting out of it. And I got the naive idea that developing the AI, the core thing, will be the toughest part, or like the most challenging part. And then it will just like naturally propagate to the world because it will be trustworthy, it will be like well-performing, and everybody will benefit out of it. And then you can like enter a new challenge and go further. And this was a very naive idea, and the reality is a bit different. And the first time I actually was able to bring a medical AI to the market was with Powerful Medical. When I joined Powerful Medical, I was aware that the AI consists of multiple steps that you have to take care of. It's the data, the annotations, you have to develop a model, optimize the architecture, do some like metrics, evaluate. All of that has to be wrapped in some technology. But then, like what? You have the AI, but it is not approachable by any user. So what you need further is some kind of a backend, something to serve your AI to the customers. And our backend team has to take care of the deployment, which can be like either nice, ugly, or totally disordered. They have to take care of the infrastructure, which can be either ugly or clean, and other stuff just to make sure that the provisioning of the AI is safety, the data are monitored, and that all just to create an API. In ideal world, we will just plug and play to the hospitals with the API, and we are almost done. But the fact is that the hospitals are not that digitalized as we would like to, so we can't really like just plug and play with them. We have to serve them an interface. In this case, we had to develop a mobile app, and our front-end team tackled with other stuff like compatibility, internationalization, localization, UX. It had to have some nice design. And still, all of this has to be backed up by other professional consultations or like know-how. And the know-how is pretty wide. You have to have know-how about the data, about the customers, about the field you are working in. You have to have developed the business model which makes sense. And still, there are a bunch of other stuff which relates to the medical AI, which has to be like brought to the market. And to mention some of these, you have to work with some solid partners, have proper processes to follow just to get certifications in medical world especially. And then you have to have a working product, lots of people, publications to be like trustful entity in the field, and lawyers, sales, tons of money, and even without the luck, the core, which is the AI, would not reach the goal, would not reach the customers, the patients, and it still can be totally useless. So this is a bit of a macroscopic view of the AI as a product. But I'm not that good at all of these layers, so I will talk a bit more about the one I am responsible for, and that is the AI. So back 5 years ago, roughly, when Powerful Medical was founded, we wondered what to do to improve the current situation in the world. The first thing was to check what is the main cause of death. And it's by solid margin cardiovascular diseases. We knew that to prevent cardiovascular diseases, there is a screening device called ECG, electrocardiogram. And there are some facts about it. Most of the, like 90% of the GP ambulances have ECG present directly in their ambulance. There are like hundreds of millions ECG scanned each year, but only roughly more than 5% GPs ever been trained in ECG interpretation besides the some semester during the study. And some more fun fact, 3/4 of the communication between the hospitals is still done by faxing, at least at the year 2017, which is like enormous number. I didn't ever seen a fax in my life. I'm glad that I didn't see it. I think I wouldn't see it in the future. So to summarize the situation, is it that there are ECGs on papers without any expert interpretation. So this is the baseline we have to work with. With this baseline, so there are only 2 steps to do. We have to digitize it, diagnose it, and then profit from what we will bring to the market. Let's go through the steps one by one. We thought that the digitization problem of ECGs is a common problem, and there has to be definitely several researches about this, how to extract the signals from the papers. Because there are billions of ECGs somewhere stored in the archives as papers, and it's valuable information, but no way to use it. And there are several researches focusing on the ECG digitization, and even if you take a look on the top cited researches, you can see that none of them really solve the problem as a whole. They all work on a pretty nice scanned ECG, just of one format, one layout, and out of those top-cited researches, only a few of them have either the code available or the data available, so you cannot really compare between them. So we thought that bringing digitization by our own will be the first good step to go through some proof of concept. And it sounds pretty easy, because everybody of you can see the curves, can follow the lines, and you can digitize it by your own. You can see the lines, and you would be able to transfer that to some digital record. And yes, that is really true. If we can see it, we can definitely code it. And it took me 10 minutes to build a code which will digitize this image. It's just 5 lines of code and 10 lines of plots, and the result is quite promising. From the original input, we are able to trace the curves quite well. So proof of concept done, we can go to the diagnostics, right? Not really, just check it, just a few more times before doing this. So we took a look to another ECG, and we can see that the digitization now struggles a bit with the peaks. They are not prolonged as they should be, but whatever, still like possible. And another example, it's definitely much worse than it should be. We are not really following the curves as we should, and this would be a bit worthless for further diagnostics. And these were the easiest cases. When we go like just a small step further, take a photo of the image. It's like almost the same image for us. We see almost the same thing, but the algorithm struggles much more. The first one is missing many of the beats. The second one did some artifacts at the end. And the last one, we can barely say that it was digitized. Like, there are some like random colors through it, but definitely not helpful for the diagnostics. And this was just the beginning. If we take a look to real cases in production, it goes crazy. There is no way that you can really have the difficult training during the AI training and easy production. In AI, you have still, like, the easiest part is the training, and when you hit the production, it is hell. And I will show you a bit of a hell we have been like seeing from our database. Some ECGs have the curves out of the grid. The grid is the reference for the voltage and time, and some of the curves are like with no grid at all. So you don't see any kind of reference for the voltage. Some of them have different weird red lightning. The other are like bended and pulled out of the pocket. The others are pulled out of the trash bin. And somebody even like, I don't know how this happened, but I imagine this is a fax like half a century ago. I have no other explanation how this could be real ECG, and people wondering why we haven't digitized this properly. Like, I think it's obvious, but it's hard to explain to the people. And this is my favorite one. Somebody used it as a scratch paper and wondered whether we can digitize this one. Well, that's not easy. And it seems that this is just making fun, but this is reality. This is out of the database of our app that people uploaded these photos and expected the digitization to work. Before showing you the results of our digitization, let's go through the process how to approach the AI development. There are several steps you have to think of, and I will give you clues how to think about these steps and when decide to go which way. So first of all, when you want to do an AI, you have to decide what approach to choose. Either you use some heuristics or neural networks. Heuristics or deterministics are often underrated because it's like the old school way of programming, but they are easy to analyze, good for explainable problems, and do not have hardware requirements which are hard, and just few data is enough to have something. On the other hand, neural networks are, or should be, faster, robust, and good for empirical problems, and definitely it's much better to say that I am a neural network developer than to say that I developed some heuristics algorithms. That doesn't sound that great. When you go with the neural networks, which is the new trend, you have to be aware of that the neural networks is just the black box. You cannot really overcome this behavior of neural networks because we are trying to be the best cardiologists in the world. And the best cardiologists in the world can definitely not tell you the right process, like the steps, what he or she is thinking of when analyzing an ECG. It's a hard thing. It's just like they see an ECG and they say it's flutter, in a second. And you ask why, and they're like, no, I can see it directly from the image. They can give you some clues, but definitely not to be able to explain everything. So this behavior of neural networks is by design not able to somehow remove. What we are trying to do is to combine the black box SIGs with the deterministics in between. So we have different stages, which all of them are separately testable and analyzable to see where in the flow happened a potential error. If you go with the heuristics, the first thing you have to describe is why it should work. We have a lot of documentation. It's all blurred and the images are censored on purpose. Don't try to read it. But it's just to give you a clue what we do with each deterministics algorithm. You have to describe it in a way that even my mom can read it and have an idea what the algorithm does without knowing how to develop it. And then you have to properly document how it works. And this is achieved by proper documentation in the code. We have strong docstrings, typed parameters, which are self-explainable, and lots of comments in the code. You can see that sometimes for one line of code, we have 5 lines of comment because the heuristics is sometimes doing some weird things. So lots of explanations through all of our code base. And everybody in company can confirm that. We have like tons of comments in every code we have. When you're going with the NN path, first of all, you have to decide whether you go with a pre-trained model or a new one. I have to say that I've been trying to improve both YOLO and PoseNet in my life. PoseNet is for detecting skeletons, YOLO for detecting objects, and I failed miserably. There is an enormous community improving these algorithms and models, and I failed to do this. So if you want to do something about the, if you want to predict something that is well-known problem and well-supported and well-researched, please use some pre-trained models. In other case, you have to bring up something on your own. For example, this is a Vietnamese ID card, and there are some, Innovatrix actually can be familiar with this. It's pretty hard to read OCR of different languages with so many accents and stuff. And using a general AI or like some Google Vision OCR, it just fails a lot. It doesn't see many of the texts, and those they translate differently. And the other thing is, I have my favorite video on YouTube, is a bit adjusted turtle, which is like considered as a rifle. And you turn around the turtle all the time, and Google Vision says it's rifle. Then if you have chosen whether you have a pre-trained or a new model, you have to decide whether you want to optimize the hyperparameters. These are good for known problems where the design, the architecture, is studied a lot. And that is, for example, the segmentation. I think that none of you can really bring up some new way of design for neural network for a segmentation problem. But what you can do is to bring something new when we are talking about something weird, something that is not that well known in the industry, and that's, for example, signals. I brought you examples of signals of an ECG. The greenish one is sound, and the vertical curves are seismographic activities. And intuitively, you can understand that there is no general signal neural network design, because all of these curve signals are from different origin. They have different behavior, different physical some kind of a relation, and you really cannot have one general signal neural network and use it. You have to bring something by your own, and to ensure that the information is propagating through the neural network properly. Then, it was mentioned also today, there is a problem called overfitting, and I know that I am a bit weird about this, but I'm strongly against the overfitting. When an AI overfits, it's not a good AI, period. If we want to be the best cardiologist or best whoever in the world in the AI model, we cannot be all overfitting. We cannot have the opportunity or the behavior or even the possibility to overfit, because the best of the best doesn't overfit at all, never. They are so experienced that they cannot overfit. And if you are overfitting, just prevent it. Prevented it by more data, more augmentation, generation of the data, or redesign the whole solution, but please do not accept ever overfitting, because that's like a signal that you are doing it wrong. Regarding the data, you definitely have to augment the data a lot. This is just a few augmentations we use when we work with the signals, with the digitization. And even if you think that the image is so disrupted that you cannot see anything, then please add more augmentations to it and it will be just right. And even better, if you can add more generated data. These data are fully artificial. They have nothing in common with a real paper or real ECG, but they seem kind of like, okay, you wouldn't recognize that these are not pieces of real paper. And it's helping the neural network to be robust to different things, to different grid colors, different ink colors, or whatever you would like to generate. And after developing the solution, you have to document it. And by documentation, I mean a lot of documentation of everything. The rule for the regulations is that even if the whole code base will blow up, you will be able to take the documentation and replicate the solution again, which will be, again, optimal and reproducible. So this is just a table of content of documentation of our AI solution, just the AI solution, not all of the layers that I mentioned at the beginning. And then if you have all documented, you have to still test it, and test it very, very thoroughly, and not like this. I was the guy that hated all the tests because they're just a loss of time. But as I grew up, I realized that the tests are the biggest gold we have in our company. And these are the things making sure that we analyze or we validate the solution accurately. So if you want to test something, for example, for the digitization, we use different ECGs with different layouts, different colors, shapes. We took a photo with different devices even. We played with the compression, with the resolution, with the brightness, contrast, even like the faded ink, and you wouldn't believe, but this was digitized. With the blur, with some background areas or some real distortions. We personally crumbled all of the papers just to have a robust test set. And if you do everything right, which is sometimes tough, in this case, I switched in one place the X and Y coordinates because pandas and NumPy, thank you. And this was the result of the ECG digitization. I call it howling infarction because there is a wolf howling on some moon and it's all with the ECG behind. But if you do it right, without these mistakes, you can digitize even the lines outside of the grid, even the red lightning, crumbled paper, or this is the crumbled one. Also, the old fax, definitely this is better to read than the previous image. And I was surprised that even the scratch paper was digitized quite well. But still, there is a long journey to get the device to the market. So thank you for your attention. I am ready for the discussion, and that's it.
Thank you, Boris, indeed. Looks like it's fun and easy to make a medical AI applicant in real life. So yeah, let's everybody go home and do this, because I especially like the 380 pages of documentation. That was really nice. Let me invite Milan again, and let's have your questions and answers, of course. So if we just switch to Slido, you can still post your questions to Slido through hashtag better_AI, and we will be able to answer them. And while you're online, you can also apply to AI Awards, so that we are not alone in there. So yeah, please do that. Okay, let's start from the top, because if you have any questions that you like and you want to post, just vote for it, and it will go up to the top of the choice. So let's start. Do doctors actually trust the predictions of the AI? And as a trade doctor of several years, I would have been deeply untrustworthy of a random tool telling me I am wrong. So how is it with the doctors? You probably know both, maybe from your experience.
Can maybe start, yeah. So if you speak about the random tool, I will also have the doubts. But there are the tools on the market which are approved and actually helps. As I said before, it must be reviewed. It's not like you have the tool which will send the patient to do surgery. If we speak about the trustworthiness, so there are some analyses, so there are some tools which actually perform better than the average radiologist. Yeah? But if you compare something with the average radiologist, you could also consider the specialized radiologist, and then you usually don't get his result. But this is already the help for some radiologists, because if the tool perform better than the average, they can give you the hints at least, even to his average radiologist.
Right. On the other hand, it's probably like with the drivers that nobody actually considers themselves an average radiologist. So everybody would expect that they are above our average now.
I don't think so, because you have the specialized radiologists in the sense like there are radiologists for the prostate cancer. Yeah, so they are really like the disease specialization. It's not like I'm better than the other, but I'm specialized in some area.
Boris, do you have experience with like real life cardiologists? You know, being challenged by powerful medical.
I experienced with both like parties, those really like cheering for us and glad that they have some like help in their pocket, and the others are a bit skeptic. But what I have to like say again, as Milan have said, it's not a random device. It is all reviewed. There are clinical studies behind it. It is not like it is doing the job properly, but still we have to gain the trust of the people. And the way how we like got the trust of the people is by trying, by like they experienced in many cases on their own that the AI had relevant suggestions, not maybe correct, but it is a relevant suggestion to think of. And sometimes it changed their mind when analyzing the ECGs and actually improved the overall diagnostics and then the further patient treatment. So I would say that yes, there will be still some like group of people like not willing to go with the app or like with the AI, but it's like a new technology that will be a standard solution in a few years, and people have to catch up with it because they wouldn't be able to be as good as without the AI support.
Thank you. Let's move on to other regarding opportunities on the markets and players like Google already building tools like MedPalm. Which parts of the market remain up for grabs to others, in your opinion?
I think there is still a lot. And the reason is that you need to be specialized and you need to look at the workflow of the doctors. Yeah? So it's not just about the model. And sometimes these very generic models, it's very hard to get them to the market because you have all, it's like was before, you cannot use just the randomly, you need to prove, and this provement means that you need to focus on something. So possibly you can basically even take this model and use it for the specialized task, and this applying of the models or maybe even developing dedicated models could be your success story. So I would not say that like market is done with.
Boris, I think you may have come over cases where you thought that this would be like the next big area for you after cardiographs. So do you have something like that?
We want to focus on the cardiographs for quite a long period to really get into the topic as deep as possible, because the cardiology is wide specification. You have still people specified in the rhythms, in blocks, in infarctions, and in different related diagnoses with a heart condition. And there is still a lot of room to bring something new, especially because there is none or just a few data for the specific diagnosis or the specific condition in heart. So even if there will be some magic AI doing quite good job with all of the data they had, they will definitely not have enough data to be that precise in the fields that are rare, but still relevant for the patient and serious to.
Yeah, so you can see yourself going, instead of going wider, just going deeper into the same field, right?
In the upcoming years, definitely that is the focus of us.
Yes, thank you. Let's move on to another one. This one is for Milan. How successful do current AI approaches in handling anomalies in radiology are? Is there a focus?
So there is specific thing about the patient with the 3 kidneys.
Yeah, a kidney segmentation of a patient with 3 kidneys.
So I would understand like some kind of the landmark detection, so segmenting the organs. So I think there's quite some progress. I cannot report on the 3 kidneys. It is very specific. Possibly could be possible. I can imagine in the kidneys. I know some organs are quite challenging, like liver. Yeah, even some doctors cannot segment from the image the livers. Yeah, so I know there is the progress work going on. We have also the segmentations of the organ segmentations as part of the product, but if we go to the specific number, I don't know from the head.
Yeah. So you know, the takeaway is have nice organs so that doctors may find them easily. Quite many products these days rely heavily on large language models hidden behind APIs, for example, OpenAI and ChatGPT. What risks specific for healthcare do you see in such approach? Basically, just approaching a large language model via API instead of probably having your own model.
Should I start?
Yeah, it's probably more for you.
Okay, so yes, there is a big challenge, and we are also looking at this, how can we actually apply, and if you also start to use these tools, you will get frequently answered that I'm not the medical chatbot. And the reason is pretty simple, that these hallucinations and these all stuff on imprecisions could be quite risky. There is one aspect that it could automate your work, but imagine the clinicians doing the prescriptions to the doctor, which will work like 90% of the time, and suddenly it will provide some prescriptions of some medicament and will overdose you. Yeah? This is high risk, so I think I would say there is good chance that and I believe it will be used in the medical devices and in the medicine, these large language models, but a lot of the problem will need to be addressed, and especially these risk mitigations will need to be addressed. So it will really, you will need to design the product in the way that it will enforce the clinicians check what was produced by these models.
So coming back to the fact that if you make an error in medicine, unlike in other areas, it can actually cost you life.
Yes.
This one is for Boris. Are your approaches applicable to other types of graphs as well? For example, electroencephalograms?
Actually, the EEGs is something that we have tested, and it works without any additional work. But it's not something we are focusing now to either certify or explore more. We just tested it, whether the solution is robust, and it seems to be, but this is still out of our focus for the next few years. But I believe that there are lots of similar cases, and this is just a computer vision problem which we have solved quite effectively. So everything that is like a curve behind some grid, which is a reference for the both X and Y axis, we should be able to get it out of the image.
Yes, and now question for both speakers. Do you see self-diagnosis with AI tools and no doctors involved in the near future, or how far? And I would just add that, I mean, we already do it even without AI. I mean, everybody, when they have a feeling that they don't feel quite well, they just Google it. So this is Google Plus, let's call it. Do you see the possibility of actually useful self-diagnosis with AI tools in the near future?
Yeah, so it's quite a risky area to even answer. Yeah? But let's me go a different approach. Yeah, so I see great potential in the patient engagement. Yeah, so you can use this chatbot for communicating with the patients, and we also were experimenting with the tools where actually before you go to the visit to the doctor, to the clinicians, you get the chatbot who will collect some basic information about you, which can speed up the diagnosis or speed up collections of the proper information. So because you need to collect for each disease different informations. And there is actually some potential, but self-diagnosis, like you will come with the output from the ChatGPT to the pharmacy, I don't see it in any near future.
Yeah. Boris, what's your opinion on self-diagnosis with AI?
I would just tell that the self-diagnostics is not very real in my eyes. I think that it will be assisted diagnostics. And as Milan have mentioned, it's all good for the prevention to get at least some information about what are the options and to be like directed to the right specialist further. So that can collect all the data, that can prepare all the material for the real specialist and speed up the process. But I think that it will be still an assisted diagnostics rather than the self-diagnostics.
Yeah, so basically more just for the automation of patient flow, you know, just so that the doctor has more information beforehand. Yep. Again, for both, would you trust your AI with your own life? If there were no more doctors, would you trust the diagnosis of your own solution to decide on the treatment? Yeah, this is a fun one.
I can definitely kick it off with yes. We have been trying this also in our office. Everybody in our office willing to like get undressed were taken the ECG and were analyzed, and we totally trusted the device. And it could make some mistakes, but like that's the thing that is mitigated, and we know about the risks. But it is like better than anything I ever seen. Like it works. If there wouldn't be doctors, that would be definitely the best predictor of the diagnosis. So without the doctor, yes, I would go with AI because there is nothing better.
Yeah.
Like without the doctors, it's really if you have nothing else, then what else is the option?
Yeah.
But I think we don't make the AI which makes the diagnosis without the doctors at the moment. That there is no such products. There are solutions which actually can help you. And there are, for example, the solutions where you can apply the AI for the first reading or until you get the second opinion. So there are, for example, the preventions of the breast cancer. You have always the two readings, and there are the discussions if one of the reading cannot be done by the AI, because then you have the second reading which can basically confirm. So even now, if you have no AI, if you have just the clinicians, then in some cases you have always two opinions, because there is a lot of fuzzy decisions even in the nowadays, even without AI. So depends on the solutions. If you have no doctors, then what else is the options? But yeah, I will be careful.
Yeah, I mean, if you apply AI for a second opinion, you basically trust it almost as a doctor.
Yeah.
Okay. Yeah. Nice. For Milan, as we are lacking doctors and they have limited time for one patient, do you think that the general AI or large language models can help analyze patient data faster? And how about the risks?
So actually, this I see as the best applications of AI in the medicine to speed up the workflows. Yeah? And this means that there is a lot of the boring stuff which the doctors must do for the radiologists, segmentations of the organs or segmentations of the cancer finding, and measuring the size of the cancer, and doing various reportings like PRADs, BRADs, and such things. And these all can be actually automated and reviewed by the doctor. So if you get the segmentations, if the radiologist say, okay, but there is some imprecisions, he can correct it, but the correction will be much shorter than doing the complete segmentation. Yeah. So for these areas, and in some cases you even don't need such high precision, so it could be even good enough what is produced by the AI. So this is actually the applications where is most potential for the AI in the medicine to speed up the workflow. And in some cases, it doesn't need to be in the medical device. It could be even speeding up, like organizing the schedule, organizing the order of the scans, and such things, which can speed up the workflow.
Automating the boring stuff.
Yes, exactly.
Yeah, okay, and let's continue with questions for you. How do you handle when AI focus on irrelevant data? In radiology, do you think we will reach a point where AI will be correct, but we cannot understand that? Or maybe we don't understand why it decided so?
Can be correct, and it's possible that we don't understand, but usually you just provide the hints. I always see the AI as kind of providing the hint, and then the human should review. So it could be that we will get the hint, we don't understand, and this is actually, we have also the feedback from the radiologists that one of the tasks is that if in some countries, I'm not sure if this is also in Slovakia, but if you get the scan and if the radiologist looks, they always get the clinical questions, decide if there is some malignancy or some suspicious lesions in the lung. But as part of the reading of the scan, they also look for the so-called secondary findings. So they need to go through all scan and check if there is something. But naturally, they focus on the clinical questions and then they just go very fast through the secondary findings task. But AI can help them because they can say, okay, there is something suspicious.
Okay.
And they don't need to know why, but they will look, yes, okay, this is something I need to focus on, and maybe decide, okay, yes, this is something really which I need to report, or no, this is false finding.
Oh yeah, so it can say that you asked me about the lung cancer, but I see other lesions as well, so you may check out.
Yeah, and in some countries they need to report on the secondary findings.
Yeah, thank you. Boris, do you have any experience with AI focusing on irrelevant data in ECG specifically?
We try to prevent some obvious cases which are easy to be defined by the either cardiologists or other specialists. So this is a topic which cannot be covered fully. Like I cannot imagine that we can check off that yes, we covered all of the irrelevant data, but yes, we have some raises in the app, raising some errors about either the data or the digitization. We sometimes reject the input that please check your lighting conditions or whatever. So we mitigate it to the depth which is reasonable for the product. I would say it like this.
Okay, and another question for you. What is the status of your project now? Where are you on the timeline that you mentioned at the beginning?
We are already certified in Europe. We got the medical device regulation, which is the official stamp by the European Union, and we already have the app in 14 countries, I guess, maybe 16, and it is used by more than 10,000 of people, physicians. So this is the current stage, and as of the timeline, we are now in the process of certificating for the US market, which is the FDA certification, and we already submitted our files. We got some feedback. We are implementing the deficiencies, and we will probably have the US certified device in upcoming months.
Okay, perfect. And I like there are a few questions that are still pointed at you. So let's start with the top one. When you use the PM cardio on ECG of my patients, what happens to the data? Is this data used for further training or improving the model?
Not really. Not for now. We still have to figure out the process of whether it will be either useful, because sometimes we got a feedback from a physician saying that, yes, you misdiagnosed the ECG, and when we got a review from the cardiologist, they're like, okay, the customer is wrong. It doesn't happen like all the time, but it happens often that the feedback we got is not valid. So we have to carefully take into consideration whether to use the data or not. So we by default use nothing. And we are focusing together the data from trustful sources, which are the hospitals and directly the cardiologist centers in the hospital to be as much confident about the reliability of the data as possible. And they have definitely handled the like the GDPR stuff, and they have it covered in their own processes within the hospital. So the answer is that we do not use the data which are like sent to the app. We do not plan to use them, and we use only our clients or partners' data.
Yeah, and one more question for you. If the solution is also targeted at the GPs and they are not specialists in reading, I mean, as you mentioned, is that a problem or challenge from ethical perspective? I think we are talking about what Milan called the overtrust, that you trust like the AI most of the time because you do not feel yourself an expert.
I think that there was some other question related to this. This is a topic for the clinical trials. You have to check it. How does that result when the GP is using the app or is not using the app? You cannot really guess it or measure it a priori. You have to really put it to production and a posteriori check what are the results. And we already had a few clinical evaluations of our AI that were completely independent in different region, different like either culture or ethnicity of the patients, and we still passed much better with the case of like being that the physician is assisted by our AI than the physician without our AI. So this is the only way how to test it, and yes, this is the result we are trying to present and like to reassure us that it has a proper impact, positive impact on the clients.
Milan, you probably have a similar experience with AI assistants.
Even if you look at the questions, so what's the other options? GPs not understanding ECG, and then average GPs, if he will overtrust and so one thing is what wins the overtrust. If you have the false negative, then you possibly miss something. But even without his tool, either his tool or the tools we are using, he will not perform better. If you have some false positive, then the worst case he will be sent to the cardiology where there are the experts. So I think, and this is actually what always you need to prove. You make your claim and you need to compare with the current practice, and if you can prove that actually with your tool the practice is better, then you actually have the proof.
When we are talking about this, are there some standard third-party benchmarks that measure accuracy and errors of ECG reading? Probably not, right?
There are some like hopes.
Okay.
There are some like activities gathering the data and gathering the annotations, but the problem is with the annotations. As Professor Bartonek says, 100 cardiologists, 101 interpretations of the ECG. You cannot really be sure about the label with the data set that were annotated just by one person. And this is something that is happening a lot. There are lots of data sets annotated by one cardiologist, but nobody have ever reviewed whether the annotations make sense. There are some standards for some aspects of the ECG, but not all of them. That is not the diagnostics. It's more about the morphology, so about the like how wide is the QRS complex, so how much time it takes to have a beat, and different morphology aspects of the ECG. For this is a standard, not very of a good quality, but is. But the community is aware of this limitation, and they are still trying to build up a new, more trusty data sets.
And since we are still at the ECGs, you talked mostly about digitizations. The question just dropped down. You talked mostly about the digitization. Have you experimented with AI-based decision-making or assistance?
That is the question I mentioned before, that it's related to the ethical or even other like interpretation or like the check whether the AI makes its job properly. And for this, there are the studies, the clinical evaluation studies through the hospitals, even the emergency system. We got covered both already, and we have pretty solid results. And sometimes it's, for me, it's fun fact is that I find it unethical to do the A/B testing when the B option is still like dominantly better. It's like, I find it weird that we are like checking the ethical aspect of it by putting some clients, some people into objectively worse situation.
Yep.
But yeah, that is how it is, and we have some results, and that all of them are like in good results with our AI.
Now, question for Milan. Is Siemens currently developing an AI-based ECG diagnosis tool, or do you just plan to buy Powerful Medical? I think we'll leave the other part for later, you know.
Maybe we will be colleagues in some ways.
Do you develop an AI-based ECG diagnosis?
I'm not aware, but the company is quite big, so we have 30,000 of employees. I know the ultrasound is somehow using ECG, so on the ultrasound you can also get the ECG, but it's completely different divisions, and I'm not sure if they even consider to use it for the analysis.
Thank you. The next question is for Boris, but I think it's interesting for both of you. Can you talk about, I mean, Boris, you started with it a bit, about what efforts does it actually take to annotate a validation set for digitization algorithm? Also a training data set as well, because as you mentioned, there's lots of opinions about what's on radiology picture, on ECG. So what's the human effort behind that, behind the annotation?
The human effort can grow exponentially. You have to design the process of gathering the data annotations wisely, and by this you can like lower it to some reasonable times. For example, our test sets took few months to finalize, and there were like 20 people involved within, and yes, it's like in Mondays, it's like equivalent to years. And you cannot really like shrink it even more. You just have to optimize it to make it a bit faster, but there is a ton of work, like ton of efforts, ton of people have helped us with this, and I'm glad that we were able to get them, because you have to, if you want to compare with the people, you have to get the people's annotations, you have to have the reference to compare with.
Yeah, Milan, how is it with the radiology specifically? You know, the annotation has to be crazy.
It's quite challenging because even the simple tasks are actually quite challenging. I read articles about using the clinical students for annotating, and these are simply not satisfactory. So you always need to very well train the personnel supervised by the expert clinicians. And then you need also the tooling, so because you need to annotation in the specific format, you need to find this good tooling. But if you have the tooling for the artificial intelligence, for the image segmentations, this maybe is not the tooling which the radiologists are used to use. Yeah, so there is a lot of the challenges, but there are of course some possibilities, as I also before speak about. The other challenge is that even if you look at the real data, so what you see is always just some shadow on the image. Yeah? And if you will look at the reports of the real life reports, what you will see is like, okay, this is very suspicious lesions, possible malignant. This is not very suspicious. Yeah? So you have a lot of the degrees of the suspicions, and now you need to classify, is it cancer or not? Yeah? So it's very hard. You need to get very trained, also the annotators, also the radiologists. You could have one radiologist which has completely different opinion as colleagues and said. Yeah. So and it's challenge. Yeah, it's really the lot of the human efforts, a lot of the effort of the experienced people, and this is costly.
Yeah, and it's, once it's suspicion and you have to transfer it into either it is or it isn't, it's quite difficult, right?
Yeah. The other thing is that in the radiology, you always need to focus there because you have to specialize, and it's different to annotate the prostate cancer from the breast cancer or from the lung cancer. Yeah, so it is a completely different task, and trials are completely different quantitative measures, which you need to take. So there is quite a lot of challenges around it.
Thank you. How is the release cycle of deploying a retrained model regulated? We talked about this actually before we even started, that how do the regulation authorities, approach a retrained model? Do you have to basically apply anew for a license, or how is it reviewed?
You need to register a new version, so you cannot just do updates without approval. Yeah, but the process is faster. Yeah, so you basically say this is the upgrade of the previous versions, and because it was reviewed before, they just used to some basics if you fulfill the regulations. But it's you need to go through the regulation.
Boris, you have an experience with this?
We are trying to automate as much as possible with this revalidation of the new model. And the thing is that it's like with the chatbots, like you can automatize a part of it, but you cannot really rely just on the automatic operations of whatever you do with the MLOps. You have to review it, you have to go through it, you have to validate it, and you have to sign it that it's following the processes and it has the desired benefits for the patients. And this can't be overcome in any way. You have to sign it. You have to be the responsible for the new version of the model, you as a company.
Okay, thank you. How can AI help achieve much more targeted cure? What's the current state, and what do you do in this regard at Siemens?
So usually for the more targeted cure, you need more data or more context, I would say. Maybe not more data in the sense of the training, but more context. And one of the approaches is clinical decision systems, where you basically try to collect as much information about the patient as possible for the given disease. You also not collect it just randomly. And then you try to compare it with the standard of practice and basically make the specific cure or specific treatment which is best fitted for the patient. Another thing which also is helping here is that if you try to make the decisions about the treatment, in the complicated case, you always need to differentiate between the basic cases and the complicated case, where there is no well-known standard how to treat this kind of the specific case, specific patients. You can look for the similar case, and you either look for the similar case in the publications, in the medical publications or medical trials, or you look at you try to find out the patients from the history which had the similar problems, how it was treated, or how the multiple such patients were treated, and what was actually the result, what was the result of the treatment. And just his finding of the similar patients actually already requires the AI task, because it's you need to know what to compare, under which conditions, what was the results. You need to actually do it through some cohort, and actually AI can really help.
Okay, thank you. Now we have a hacker question. How come neural networks are so robust? Prompt injection and adversarial attacks say otherwise. So, what's your opinion about just hacking neural networks? I'm not sure if that's applicable too much, because this is like more for large language models, but
even in this you could theoretically have it, you can possibly find it, but you are in the very controlled environment. Yes, you get the data from the patient. You should keep also the privacy of the patients, then you get it for the analysis of the AI or AI-assisted diagnosis. So it's assisted diagnosis that's always needs to be kept in the mind, and then you basically can make the decisions.
Yeah.
I don't know that somebody make really the deep analysis, and it's also not very generic. What we use currently in the medicine is case narrowed. Yeah? So you have some purpose, and for this you don't deliver like generic AI for each kind of the disease.
Yeah, let's continue with generic AI. We have the last two questions. So first, let's say the general AI and specifically LLMs will likely be used in medicine. I mean, you mentioned it as well. Can you imagine some way how to check if it's actually not hallucinating? If it's, if the answers don't contain like these obvious errors, like you mentioned, the possibility of overdose for, recipe and so on.
So at the moment, so it depends always on the use case. Yeah, for example, the information extractions, like you have the patient report and you want to extract the specific informations, there will be always the risk, and you always will need to review, and actually, even if trying to use it, still not big trust in this. Also, there's still a lot of the investigation ongoing if this can actually be used for such task. Yeah? So it's possibly hallucinating. You need, again, it's not about, I would say differently. If you are the programmer and you use the LLMs, it not always gives you the right answer. It gives you the half of the time right answer, or the half is maybe crap, yeah? But still, you save a lot of the time, because half of the time you get something which you can use. In the medicine, you can imagine similar things. Yeah, for example, imagine patients, 70 years old patients, coming to the clinicians with the stuff of the reports.
Oh, yeah.
Yeah, and you need to find out if there is some suspicious disease in the former times, in the history of the patients. And the patient is maybe not hearing you properly, not really mentally well. Yeah, so there is a lot of the other problems. And you have like 10 minutes for the patients, yeah, because you have a lot of the patients. Then even something which will give you the hints would be very helpful. Yeah? Just maybe, okay, don't overlook there is something. Yeah, and this could save a lot of the time. So these use cases can be helpful, like really going to the prescriptions or generating the report with the risk of hallucinations. There is a lot of the risk. Yeah? So you need to look where you use it, how you mitigate the risk.
Yeah, I think this is one of the recurring themes today, that we are not really looking for a perfect answer, but just improving the current state and condition. Okay, let's move to the final questions. How much easier for Boris did working on your solution get after you were able to correctly digitize the ECGs from paper, especially from the crumpled ones, possibly? Yeah.
The crumpled ones are not very the use case, which is often like relevant.
Yeah.
But it is a fun fact you can bring and like make some impressions.
Yeah.
But the real thing is that most of the hospitals do not work with the research centers because they do not have the API how they can work together, because the hospital do not have digital data, they do not accept anything else than digital data, and they are like, like the cooperation ended. In our case, the digitization is the foot in the door. Like we either if we will trade just the cooperation by digitizing them some data, they are super glad to accept that, because they have like the ECGs in their archives, which are of potential, but not used because they cannot really utilize them. So this helped a lot. This is why we are easy to get to clinical studies, because we can integrate with their system, which is like none. They don't have to have anything, and they can really easily like pull out the app, downloadable in the App Store, and take a photo, and voila, you have the results.
Yeah, you don't have to buy like a huge scanner or whatever. Yes. Okay, thank you. Thank you for your answers. I'm really glad that you have come here and talked to us about, how medicine could improve in the coming months and years with the AI. Thank you all for coming and for listening to us online as well. On behalf of Kinit and Innovatrix and Nadacia AVS Foundation, thank you really. And when you're online, don't forget to check the AI Awards. And since this is the last Better AI Meetup this year, so I wish you all good health with or without AI, but hopefully next year at least with Better AI Meetup. So thank you and good night.
Thank you.